So let's see how to create, how do we define a thread? What are the steps to define and create a thread object? Let's see. There are two ways to define a thread. One is by extending thread class, and second one is by implementing runnable interface. Okay, we can define a thread by extending thread class or by implementing runnable interface. Implementing runnable interface. Say, extending thread class. What are the steps to define a thread by extending thread class? First, create a class which extends from thread class. Create a class extends from thread class. Like class, let's say my thread extends thread. Okay. First, define a thread by extending from thread class. Class my thread extends thread. The main objective of creating a thread is to execute a task. Execute a task. Why do we create a thread? To execute a separate task. So, assign a task to the above thread. Assign a task to the above thread. So, in order to assign a task, in order to assign a task, run method must be overridden. Run method must be overridden. We must override the run method. In order to assign a task, run method must be overridden. Like class my thread extends thread, override the run method. Okay, run method override, and here code to be executed separate thread. Right, whatever code you write, that code will execute as a separate thread. Whatever task you write, that will execute as a separate thread. Okay. Class my thread extends thread, override run method. Inside the run method, whatever code you write, that code will execute as a separate thread. Okay, this task will execute by separate thread. Then start the thread. Start the thread. How do you start a thread? So you can call, first create a thread object. Create a thread object. This is defining a thread, not creating a thread here. Defining a thread. Here we are creating a thread object. Creating a thread object. You can write my thread dx1 equal to new my thread. Okay. Or thread dx1 equal to new my thread. Why? Because It's the parent class now. This class is extended from thread class. Thread is the parent class. So parent class reference can point to child object. Thread tx1 equal to new of my thread object is created. Once thread object is created, start the thread. Start the thread. To start the thread, you have to call tx1 dot start. You need to call the start method. To start the thread, call the start method of thread class. Now, start method will call run method implicitly. Okay, start method will call run method implicitly. Whenever you start the thread, start method is going to call the run method of that class. Now, the code written in run method will execute as a separate thread. Then, after completion of run method, after completion of run method, thread enters into dead state. Once the thread is dead, it can't be restarted. Once the thread is dead, it cannot be restarted. Okay, these are the steps in order to define a thread and assigning a task to the above thread. Whatever the thread we are creating, we will assign a task. Now let's do it practically. We will follow all the steps now. We'll create a class. The class will be extended from thread class. Override the run method. Inside the run method, we will write a task. Whatever I did yesterday, some of the numbers. So those things will put it inside the run method. Right? Okay, say let's create one as a thread demo. Class name is a thread demo. Observe here, so we'll create class task1. Okay, and class task. See, first of all, I'll show you if we don't make it multi-thread, what could be the problem? Then we will convert it into multi-thread model. Huh? Don't try it now, just look at it. Task 1, task 2. Inside task 1, I'll write a method void task 1. Okay, sum equal to 0, I equals to 1, less than equal to 10, plus sum equal to sum plus I, and display here a message I added. I added. Display 1 added, 2 added, 3 added. I equal to 1 is added, then click 1 added. After that, I want to display thread dot sleep. After 1000 millisecond, under 1 second, after 1 second, one more number will be added. Okay, it will keep adding the numbers after 1 second interval. After 1 second interval, so you will get 1 added. After 1 second, you will get 2 added. After 1 second, 3 added. I am giving thread dot sleep. Sleep method will delay. The thread will do nothing for a given time. Okay, the thread is in the sleep mode. Sleep for 1000 is the millisecond. 1000 is the millisecond. It takes the input in the form of a millisecond. It is 1000 millisecond. Why I am giving 1000? Because I want to delay 1 second. Okay, I will delay 1 second. So 1000 millisecond is 1 second. It throws an exception actually, unhandled exception. Unhandled exception, interrupt exception, checked exception, right? It is a checked exception. So we can put it here now. Right. Gas interrupted exception P. Okay. Then once you come out of this loop, display here sum equal to sum calculated by thread dot current thread output gateway. Okay, thread dot current thread dot gateway. Okay, so this is the task 1. For this, put it here now as a make it task 2 now, and 11 to 20. Okay, task 2. Now what I will do? Here if I create task 1, T1, new of task 1. Okay, I will create task 2, T2 equal to new of task 2. Okay, we create the object of 2 class. Task 2 class, task 2 1 class. Then we call this methods T1 dot task 1, T2 dot task. Apart from this, if I write one more method here, observe and try here. This is 21 to 30, suppose 21 to 30. Okay, then this. If you run this code now, what will happen? First, task 1 will be called. Okay, task 1 will be called. We will be getting sum of 1 to 10. Sum of 1 to 10 will be getting. Okay, sum of 1 to 10. In 1 second interval, you will be getting one number. After completing 1 to 10, then task 2, 11 to 20. After completing this is my task 3, which is then the main method. It will be 21 to 37. So the execution will be in sequence one after other, right? It's completely sequential execution. Only one path to execute the whole program. So you can see now every 1 second is getting wasted. 1 second. After that 1 second it does nothing. But still waiting for that task to complete. After completing task 1, 2 started. Then after 2, 3 will be started. Main will be started. But what is my requirement right now? Now you can see it is happening sequentially, one after other, right? But I want to make it multi-threaded. Then what will happen? 1 added. After adding 1, it is waiting for 1 second. 1 second, it could have come to second task and 11 added. That 1 second wasted here. So when 1 is added and after adding 1, sleeping for a second, thread 1. When sleeping for 1 second, it will switch to other task. Other task 11 should be added. After adding 11, again it is waiting for 1 second. It will switch to where now? 20. So parallelly it can do 1 added, 11 added, and 21 added. After that 2 added, 12 added, and 20. At a time parallelly all two things will happen. so that time will not be wasted here. And the order cannot be predicted. As I am telling you, like 1, 11, 21, 2, 12, 22. This order we cannot predict. We do not know in which order it will switch from one task to another task. But switching will happen. Switching will happen from one task to. So that is the reason why I have taken sleep method to let you understand how switching is happening from one thread to another thread. Okay. But now this program, it is not a multi-thread program. It is a single thread program. No matter how many times you run the program, the order of execution will be same only. First task 1, then 2, then 3. But when you make it multi-thread, one thread is responsible to execute this task. Second thread is responsible for this task. And main thread is responsible to execute this task. And which task will get over, we do not know first. We can predict task 1 will complete first or 2 will complete or main. All 3 tasks started simultaneously, but which task will complete, we do not know. It's something like 3 people are initiating a request for 3 different tickets in 3 different counters. Who will get the ticket first, we will not know. Even though at the same time the request was initiated by all 3 clerks. But who will get the ticket, that cannot be predictable, right? All 3 requests are generated same time. Similarly, all 3 will start now. Task 1, thread 1, thread 2 and thread 3, main thread will start also. Which thread is going to complete the task? We do not know that. That cannot be, the output cannot be predictable. See, my objective is what? All my tasks to get over. How it is happening, that not matter. In which order it is happening, that doesn't matter. Okay. So, in this case, always we will get the same output. It's a predictable output. Always 1 to 10 first, then 11 to 20, then 21 to 30. So, first we will get 1 to 10 sum, then 11 to 20, then 21 to 30. But if I make it multi-thread, we will not know whether sum equal to 55 will come first, or sum equal to 155 will come, or sum equal to 55 will come. We do not know whether this will be calculated first or this one or that. Now let's convert this into multi-thread application. To convert this, what I do? The task 1 is there. Take task 1. Simple task 1 extends from thread. Okay, task 1 extends from thread. Create a class, extends from the thread class. Then, once the thread is defined, the objective of this thread is to execute a task. Which task? This is my task to be executed by the thread. This task has to be executed by the thread. Then what you do is override run method. Override run method. What I said, whatever logic you write inside the run method will execute as a separate thread. So the whole thing I can put it inside the run method. Otherwise, already the method is there, task 1. Don't write the whole thing, just to call here what now? Task 1. Call here task 1. Calling task 1, nothing but this code is present inside the run method only. Isn't it? Already the method is there. Why to put it again inside the run method? This method we are calling from the run method. It means inside the run method this logic is present right now. So this code is going to execute a separate thread. Okay. So task 1 extends thread class, override run method, and it is the task to be executed separately. Similarly, class task 2 extends from thread class. Okay. Then override run method. Okay, run method. And call here task 2. Okay, so we are done with task 1 and task 2. Anyway, main thread will initiate when we start the program. Main thread will create. You can write task 1 T1 equal to new task 1. This is a kind of thread. This is a kind of thread because task 1 is extended from thread class. Yes or no? Task 1 extended from thread. Task 2 also extended from thread. So task 1 is a kind of thread. Task 2 is also kind of thread. Otherwise, you can write it this also. As I told you, thread T1, thread T1, thread T2, T1, thread T1 equal to new task 1, T2 equal to new task 2. So this is the parent class, child class now. Parent class reference pointing to child class. Okay. After that, what I have to now? Once you see the steps here now. First we create a class now. Then override the run method. Then we wrote the code to be executed. Then create a thread object. How? Thread the ts1 equal to new my thread. In that will be created thread t1 equal to new task 1, thread to new task 1. After that we need to start the thread. We need to start the thread. So don't call task 1 and task 2. Call t1 dot start, t2 dot start. Okay, both the threads started. Okay, when t1 start, t2 start. T1 start will call do now. Start method of t1 will call the run method of t1. Run method of t1. T1 dot start. Start will call run method of t1. T1 is what? Task 1. So this run method will be called by thread 1. This run method will be called by thread 2. And this run method is calling this method now. Task 2. Okay. After this T1 start, T2 start, this is the task of the main method. In this case, you cannot predict any order. You might be thinking T1 dot start at first T1 will execute, then T2 thread will execute, then main thread will execute. No. When you say T1 dot start, immediately it may not call run method. When you say T2 dot start, it also may not call run method. Even though both are started, the main thread might get a chance, so you get 21 added first. Later you get 1 added, 11 added. Why? Because start method does what? Start method calls run method, no doubt, but not immediately. The start method does what? It registers the thread with the thread scheduler. There is a thread scheduler who will decide which thread will get the chance to execute, get the CPU time now. When it's a T1 start, T2 start, both the threads will be registered now. T1 and T2 both will be registered with whom? Thread scheduler. The thread scheduler will decide who will get CPU attention. Whichever thread will get CPU attention, the run method will be called. So calling start method is nothing but it's ready to run. Ready to, not running, ready to run. At any time it might get a chance to run. That is the objective of start method. When it's a start, it does not mean that immediately T1 will start or T2 will start. Start method enables both the threads now ready to run. At any point of time, both any one of them might get a chance to execute. Both are ready, but not they are in the ready state, not in the running state. That is ready state or called runnable state. Runnable is ready to run. Ready to runnable and running is different. Running means run method is executing. Inside the run method that is called a running, and when it's a start, it is the runnable state, ready to run. Okay. Now you run the program, you see the output now. See what happened first now? We got 21 added first, right? Even though T1, T2 started 45, 46 line number you see. T1 dot start, T2 dot start. But which thread got the chance? T1, T2 did not get it. Which thread got the chance? Main thread got the chance. 21 added. 21 is main thread. After that, 1 added. 1 added T1. Thread 1. This is thread 2. See, the order is what? Main, thread 1, thread 2, right? Again here, thread 1, main, thread 2. Again main, thread 1, thread 2. Thread 2, thread 1, main. You can't predict every time the order might not be guaranteed also. Okay, so that we cannot predict. Depends on CPU how it is switching from one task to other task. And finally, what happens? Which one completed first? thread 0 and first thread. By default, the names are thread 0, thread 1, thread 2. First thread is thread 0. Second thread is thread 1. So now which completed first? Thread 1 completed first. You see now 10, 20, 30. 10, 20, 30. Okay. So 10 this is completed. Now immediate 20 is also second. 20 is done. 20 is the second thread, right? Second thread, and 30 is the main thread. So you got thread 1, main, and thread 2. Okay. So now observe here. One main, thread 2 is there, right? One main, 2. Once again run it might be different. So now 21 after 11, 32 got the chance. You see the order is last. Main completed first, then thread 1, then thread 2. So you can't predict at all. Different execution time, different output might have a different order might come. Output the same only, all three tasks the same only. But the order might be. See again, thread 1, main, and thread 2 has come. Okay, all three tasks are getting completed, but the order cannot be predicted. Parallelly, it is happening, three things happening. 21 added, and it is waiting for 1 second. 1 second again, 1 added. After adding 1, waiting for 1 second, going to other task 11 added. Now we are getting down to this 21, 1. Last time it was done for 1 to 10, 11 to 20, 21 to. It was in a sequence. Right now it is not in a sequence. Parallelly, three tasks are right now because we have multiple threads. There are multiple independent paths of execution. But initially it was a single independent path of execution. If the program contains single independent path of execution, that is a single thread application. If it is having multiple independent path of execution, it is a multi-thread application. Okay? Okay, few points you need to remember here. When you call start is calling to method, run method. Okay, you see that start is calling to run method. So why don't we call run method directly? Why don't we call run method? If I call run method directly, t1.run, t2.run. You call t1 and t2 run directly. Then it won't execute as a separate thread. It will assume like it's a normal method. We are just calling the run method. Run method is present in the task 1. We are just calling the run method as a normal method call. It won't execute as a separate thread. You see, sum equal 55 calculated by main thread. You can see the execution process itself, the sequence cell. Again, 155 calculated by main. All the tasks calculated by main thread only. Because I did not start the thread. Directly I am calling the run method. Okay, so it is always recommended, and it is always you must call start method to start the thread. Never call run method to start. You call run method, it don't execute as a separate thread object. It is a normal method call. So never call run method. Okay, so never call run method to run a thread, and always call start method to start a thread. Okay, to start a thread, always call start method. Now see, I am calling start method. Start method, when you call t1.start method, start method belong to which class? Thread class. Start method belong to thread class. So t1.start means start method belong to thread class. Thread class start method calls run method of your class. This run method belong to your class, but start method belong to thread class. So when you say t1.start, start method of thread class makes a call run method of your class. So this is I will write start method here. I'll override start method. The start method is present in thread class. If you override, now this method will be called, right? And from this method I will call explicitly what now? Run method. The start method has to call run method now. So I am writing start method and calling the run method. Here also. Start method and call the run method. Then you call start method run method. Now observe what will happen. Now also it won't execute separate because you should not override start. Always start method of thread class should make a call to run method of your class. You should not override start method. Why? Because start method is not only calling the run method. Start method which is registering the thread with the thread scheduler. That is not happening here. Okay. So if you run again, not execute the same single thread only. Single thread. So 1 to 10, 11 to 20. That's why what is the learning here? Never override start method. Always override run method. And never call run method. Always call start method. Whenever we want to start the thread, always call start. Start will call run method internally, but you don't call it. And you don't override the start method. Okay, start method is already there in the thread class. So thread class start method will make it internally make a call to the run method of your class. So you must override run method. If you don't override, it is not an error because thread class is also having a run method, but that is an empty method. No task is written there. That's why we have to override run method, and whatever logic you write inside the run method, that will execute as a separate thread. That's why it is always if you don't write run method, it's of no use of creating a thread also, because we are not assigning any task to the thread. So we should not override this. So, never override start method. Always override run method. Okay, never override start, always override run method. Here also, just comment it. Don't. Okay, run the code. Now we'll be getting a separate thread. Okay, and now let's change the name of the thread here. By default, the thread names are coming as thread 0, thread 1, thread 2, right? Thread 0, thread 1. I mean, even main thread also, if you want to change it, you can also change it. Yesterday we saw now the thread properties, name of the thread and priority, right? Name of the thread and priority. How to get the name of the thread? Get name, right? Get name. So that's a method called set name. By set name, we can change the name of the thread. Get the priority, getting the priority. Set priority, so you can change the priority also. So for example, I want to change the name here. Thread T1 new task. Set T1 dot now. Set name T1 dot set name. I said side 1. Thread 1 name is side 1. T2 dot set name side 2. T1 dot set name, T2 dot set name. So name is changed for T1 and T2. Even I want to get the, say here, thread dot current thread dot get name, and you are reading the main thread, right? Reading the main thread. If you want to change the name of the main thread, change the name of main thread, what to is initially do like this. Thread dot current thread. We give the current thread object dot set name dot set name. So results main thread. Thread dot current thread dot set name main hyphen thread. So the name of the current thread is what right now? Main thread. And T1 name aside one, T2 aside 2. Right? So now T1 got the chance, thread 1 got the chance. Okay, thread 1, then thread 2, then main thread got the chance. Again main, thread 2, thread 1. So what you got now? Main thread, child 2, child 1. Before it was coming up, thread 0, thread 1, hyphen thread. Now child 1, child 2 and main thread executed. Right? So this is the way like we can change the name of the thread. The same way we can change the priority also. Priority. The purpose of priority is to see, suppose we have multiple tasks to do. Okay, we have multiple tasks to be completed. Then what we do? We prioritize the task, right? Which is more important? We will do that first because we have a lot of work. We need to prioritize which one has to be done first. Based on the priority, we will do the task. Similarly, here also we can prioritize. We can give high priority. Whichever task is having high priority, so it is just a request. It may or may not be request may not be honored by the CPU, but it's just a request because it has its own algorithm. Operating system has its own algorithm to execute a task. But still, being a programmer, we are requesting, and very often it might happen also. The thread which is having high priority, very often that thread will get the chance to execute first. Okay. So how do you change the priority here? T1 dot set priority. T1 dot set priority. Then you can give the new priority. The priority is in the form of what? Integer. Priority is form of like 1 to 10. 1 is the minimum priority, low priority. 10 is the max priority. 5 is the normal priority. So we can give, suppose that's a 10 now. And a high priority is a high priority. Otherwise, what you can do? Thread dot thread is the class. It has got 3 properties. Final properties, static final properties, public static final. One is called mean priority, max priority, and normal priority. Then we have the max, mean, and normal priority. And max priority. Thread dot max priority means what? It is a priority is 10. Okay. Or even we can write like a suppose max priority minus 2 and then priority is 8. Priority is by default priority is 5 every thread, including the main thread, whichever thread you create now, the default priority of all the threads are 5. If you want to change the priority, you can use set priority method, and you can use thread dot mean priority max, okay, or max minus something, mean plus something, normal plus normal minus, or directly you can write number 1 to 10, any number you can write. But if you write it, it's a more readable. Right, other writing 1 to 10, 1, 5, 10, if you use a minimum priority, normal priority, you can, it's a more readable. You see the constant. Public, static, final, int, constant name is what? Max priority. Its value is what now? The maximum priority that a thread can have is this. Okay. Constant field values you can see. Like 1. Let's see. Yes. Minimum priority what now? 1. Normal is 5. Maximum is 10. Okay. These are the variables. The same. These are the java.lang.thread. Inside thread, these are the three constants. Constant fields are this. This is the name of the constant. The type, public static final, the value is 10, 1, and 5. Like this. Different classes, we have different constants. All the constant in Java 8, all the constant, only constant list given here actually. So now let's see. Let's say set priority max minus 2. Run it now. See, initially not started, as I told you, it might not start very immediately, but very often it will get a chance. So now, first thread not started. High priority is given to thread now, T1. Okay, but second thread got, now see 2. Then again what now? 3 with the 4, 5, 6. Which thread is getting the chance? First chance. 6, then 7. First thread only. 8, 9 and 10. First time did not get. First time we started with the thread 2. But the second time onwards, what happened here? Okay. So second time onwards, 2 added. This is the list, right? Second iteration. 2 means thread 1. Again, thread 1, thread 1. Every time thread 1 got the chance because this parent is a maximum priority -2. As compared to child 1, child 2 and the main thread, it has got more priority. So this thread got the chance very often. So very often if you just sit 10 times running now, very often thread 1 might be there. And every time you will find thread 1 will complete first. Thread 1 will complete its task first because it has got more priority. If you give less priority, it will always execute mostly. If I say minimum priority, suppose I will give here now. Minimum priority. 6, 4, 5, 6 last, 8 last. So it's calculated. Last side one is completed. Last is complete because of its minimum low priority. Okay, so this is just a request to the operating system that please execute as a high priority or low priority. We can assign the task with multiple tasks. So this is the way like how we can create it. So for each task, you create a class, extends from thread class, override run method. Inside the run method, you write the task. Whatever you want to execute as a separate thread, put it inside the run method only. Complete direct code you can write it or write a separate method and that method you can call from the run method. Okay, this is the way like creating defining a thread by extending thread class. Similarly, we can define a thread by implementing runnable interface. Implementing runnable, same steps only. Okay, same steps like we will create a class. Instead of extends, we will write implements because it's implementing is an interface now. It is an interface. So create a class, implements. Interface name is what now? Runnable. Then same thing, override run method, write the code, create the object. Object creation will be a bit different. There are 2 steps will be there. Why? Because directly now when I am saying thread ts1 equal new thread, it is a thread object. It is a thread object. But whenever your class is implementing runnable interface, your object is not a thread object. Your object is not a, it is a runnable object. It is a runnable object. So I have to create a thread object by taking that runnable object. So one more step we need to add here. While creating thread object, one more step we will add here. After creating that, again as well, start the thread. Start will call the run method. Same process will go. Okay, only one step we will add here. While creating a thread object, there are 2 steps. First, create a runnable object, and by taking that runnable object, create a thread object. Create a thread object. Then same process. After creating the thread, same you can call start method. Start will call run method as well. Go. That is implementing runnable interface. We'll see that Monday. I'll tell you how to create a thread by implementing runnable interface and which is recommended approach. We'll see by extending thread class, defining a thread, or by implementing runnable interface, defining a thread, which is the best approach among these 2 approaches to defining a thread. Then Monday itself we will discuss. Now each thread contains their own resource. Now thread 1 has its own task, thread 2 has its task. We will see, suppose one task, multiple threads. Here each thread has got its own task, separate task, separate thread. But we will see, if the task is one, but multiple threads are there, multiple threads are going to execute the same task. Okay? One resource shared among multiple resources, multiple threads, then what could be the problem and how do you resolve it? That is called synchronization, thread synchronization. Okay, thread synchronization and thread deadlock. Okay, deadlock and thread communication. Okay, these three things are there. Thread synchronization and thread deadlock and thread communication. How the threads communicate with each other. When multiple threads are running in an application, how one thread can communicate with the other thread by using, there are three methods are there: wait, notify, and notify all. How to use these methods in order to establish the communication between the multiple threads. You might have studied in your operating system interprocess communication, IPC, interprocess communication. Similarly, here inter-thread communication. Inter-thread, how the process gets communicating from one process to other process. Here, thread also gets communicated between. See, yesterday I was telling you, it's a lightweight process. I forgot that time only. So, lightweight process, why it is called? Because when there are multiple processes, switching from one process to other process takes time. Because every process has got a different memory space. But coming to thread, switching from one thread to other thread will not take much time. Because within the process it will run. One process, whatever memory is allocated for the process now, within that process the thread will be generated. So switching will happen between the same process only. So it does not go to the different memory space. And it uses the resources allocated for that particular process. That's what it's called as a lightweight process. Okay, that is a lightweight process. So these three concepts are there. We'll see. We discuss one time. We'll try to complete. If not, one more class might be required for this. Okay. Next to this, we'll say we'll start with the collection. We'll start. Okay. Thank you.